You are asked to determine the density of a material of a thin uniform wire of length about 15 centimeters. Right? That is important, about 15 centimeters, because when we are asked to find the device to be used to find lengths, those things, right? 15 centimeters is needed, right? 15 centimeters and mass about 200 milligrams. Okay, 200 milligrams. You are provided with the micrometer screw gauge shown in figure 1 to measure the diameter of the wire. Right. Name the parts of the micrometer screw gauge. Right. Very straightforward. Name the parts of the micrometer screw gauge marked as AB. Marked as AB, not the two scales. Right. Okay. Not the two scales. Right. And C. Then what is a sleeve? Right. A is not the scale. Right. That's a sleeve. A is sleeve. Sleeve. Right. Then B. B, thimble. Straightforward. Thimble. And C, thimble head. B, thimble head. Thimble head is also called the ratchet. Sometimes, right? Ratchet के लिए वो तावलन है. Thimble head or ratchet. Right. B. The main scale of micrometer screw gauge is made by dividing 1 millimeter into 2. The circular scale has 50 equal divisions. One complete turn of B will either increase or decrease the distance between the anvil and spindle by a value which is equal to 1 division of the main scale. Equal to 1 division of main scale. Right? Now this is made by main scale is main scale is made by dividing 1 millimeter into 2. Right? What is the pitch of the micrometer screw gauge? Then that is 1 millimeter over 2. No? Pitch is 1 millimeter over 2. Then 0.5. It is 1 millimeter over 2. That is 0.5 millimeters. 0.5 millimeters. Right? Next one. What is the least count of the micrometer screw gauge in millimeters? We know least count is given by, right, pitch over number of divisions in circular scale. Pitch over number of divisions in circular scale. Then this is given by pitch over. No need to write the equations. I'm writing the equations for your reference. Right? Otherwise, no need to write the equations when you are answering this. Right? Pitch over number of divisions in circular scale. Pitch here is 0.5 millimeters. Number of divisions in circular scale 50. Then that is 0.01 millimeters. Right? 0.01 millimeters. Next one. Figure 2 shows the position of circular scale when the anvil and spindle touch each other. So we know zero error is checked by touching anvil and spindle each other. Right now, this is going to check the zero error. Touch each other. Determine the value of the zero error of the micrometer screw gauge in millimeters. Right. If zero is above center line, that is a negative error. Right. If zero is above center line, that is a negative error. Right. That's a negative error. Then this negative zero error is always total minus coincided. No. Coincided divisions is 45, 46, 47, 48. Right. Then total minus coincided 50 minus coincided into least count 0.01 millimeters. That is 0.02 millimeters. 0.02 millimeters. Right. Then after determining the zero error, state how the micrometer screw gauge is used to measure the diameter of the wire. Right. Now zero error is known. Zero error is known. Right. Then to measure anything using micrometer screw gauge, we have to keep it in between anvil and spindle. And we are rotating. Right. You are rotating the thimble head. Right. You are rotating the thimble head until a ticking sound is heard. Ticking sound is heard means that is firmly tight in between anvil and spindle, right? Without over pressing or over pressurizing, right? Without being over pressing, over pressurized, that is firmly tight, right? That is firmly tight. If one second, that is firmly tight if ticking sound is heard, right? And then since we are taking a diameter of a wire, I have to take minimum of two readings in two perpendicular directions, right? Then two parts asked, no? Then have to mention both accordingly, right? Then write down the first one. Write down the first one. Keep the wire. Keep the wire in between anvil and spindle. Keep the wire in between anvil and spindle. And rotate thimble head and rotate thimble head until a ticking sound until a ticking sound is heard. Until a ticking sound is heard. Right? Then the other thing is we can't satisfied. We can't get satisfied just by one reading because that's a wire. That's a wire, right? Higher the number of readings we can take, right? Higher the number of readings, you can have higher the accuracy, right? The minimum two, minimum two, right? Then take minimum two, or you can say several readings. Take minimum two, take minimum two or several readings in perpendicular directions. In perpendicular directions and take the average. Right? So those things must be there. E. What is the purpose of having part C in micrometer screw gauge? What is part C? Part C, thimble head. I just mentioned the purpose, right? To avoid overpressing or over pressurizing the wire or the object because any object that you are keeping in between anvil and spindle, right, cannot be overpressured, because if that is overpressured, what happens is its cross-sectional area is going to damage. When cross-sectional area is damaged, you are not going to get the exact correct reading, right? So that's the idea. Then write down to avoid overpressing of the object or wire kept in between anvil and spindle. Right? F. Figure 3 shows the position of the circular scale when the diameter of one place of the wire is measured using the micrometer screw gauge. Mentioned in C above. What is the reading of the micrometer screw gauge in millimeters? Right? Just take this reading. Only 0.5 is completed. Then from main scale, reading is 0.5 millimeters. From vernier scale, right? 5, 6, 7, 8. Then 8 coincided divisions, 8 into, please count 0.01. Right? Then 0.58, no? 0.58 millimeters. What is the correct value of the diameter of the wire in millimeters? Correct value. Right? We know we had a negative error of 0.02, no? Then correct value is 0.58 plus that 0.02, that is 0.60 millimeters. 0.60 is not a word mark. 0.60 is a must. 0.6, just 0.6 is not a word mark. 0.60. Calculate the cross-sectional area in square millimeters of the wire using the value in F1, 1 and 2. F1, 2. Ne? All right, this one. About A 5 equals 3. Then A equals, we know area is 5r squared, no? Right? 5 is 3. And this is diameter 0.6. Then radius is 0.3 squared, right? Simplify 3 times, right? 0.3 means 3 times 10 to the power minus 1, then 9 times 10 to the power minus 2, 27, which means 0.27 square millimeters. 0.27 square millimeters, right? A small simplification. G. What other measurements do you take to determine the density of the material of the wire? Density, right? To find density now, what we only know is the area. Then we have to have the volume. To have volume, we need length. Then length of wire. Right? And second one, obviously we need mass, because Density is mass of volume. Then mass of wire. Mass of wire. Right. Second one, name the most appropriate measuring instruments needed to obtain the measurements mentioned in G1 above. Right. Then to find the length, it says initially it was given as 15 centimeters, no? 15 centimeters. Then to get a reading like 15, what we have is meter ruler. Meter ruler. Then in this correct order, you have to mention because numbers are given as 1 and 2, meter ruler. Right. Then to measure mass, mass of fire, mass for mass also a hint was given as 200 milligrams, right? 200 milligrams, 200 milligrams. Then to measure mass like 200 milligrams, right? So either you have to go with electronic balance or four beam balance. Electronic or four beam balance. Chemical is also fine, but no need to go into something like chemical. Electronic or four beam balance is fine. Electronic or four beam balance is fine, right? Otherwise, triple beam balance is not suitable because its least count is 0.1 grams, which means 100 milligrams, right? 100 milligrams, least count is 100. Then the reading you are going to take is around 200. Then percentage error is very high. Percentage error is very high. Then triple beam is not suitable. It should be either four beam or electronic, right? Either four beam or electronic balance. Either four beam or electronic balance, right? H. Figure 4 shows an electronic micrometer screw gauge used in industrial applications. What is the least count of this gauge in millimeters? Here reading is given, no, see, 6.467 millimeters. Then readings are given up to 3 decimals. Then least count must be 0.001 millimeters. Least count is 0.001 millimeters, right? Right. So that's it for question 1, right?